is the exam wrapper for Physics 2212, and I will discuss about the problem that I have most issues with during the test, which was problem number 1. So, problem number 1 requires you to locate a charge so that the net electric field is 0, and also involves drawing electric fields as vectors within the xy plane. So let me first read the problem statement. The problem, it requires you to do 3 particles are located on the xy plane as indicated in the diagram. This is the diagram. The first particle, Q1, is equal to E and is located at minus D, 0, 0. The second particle, Q2, is equal to 3E. It is located at 1.91D, 0, 0. The third particle is equal to minus 2E, and it is located at minus D, 2D, and 0. Note that E is the charge of the proton, and D is a positive distance. But now, let's go to question A. Draw the direction and approximate magnitude of the electric field from the 3 charged particles at the origin, and label each field. So then, what's the fundamental principle that you need to apply? The fundamental principle that you have to apply is that for every single charged particle, you will always get an electric field. So now, this is the relationship that describes between charge and field. And we shall first determine the electric field in symbols for Q1 by first determining the r vector, which is the distance between the observed location and the source location, so the location of the charge, 1. Then determine the magnitude, that unit vector that describes the direction, and then plug all of this into that same equation here, but for here, apply it into this scenario, and you get this final value here. Now, if you want to draw it, since the x is positive and the others are 0, we shall draw an arrow that points towards the right of this assumed magnitude. And I'll label it as E1. Now, we will apply the same analogous procedure for both Q1, Q2, and Q3. And these are all the solutions. So you can notice that, excuse me, I forgot to put a sign. You can notice that you can draw from this one that since x is negative, and since you can notice that this is smaller than this x, because this is like 1, and this is like almost 3/4 of it. We can then just draw it with the E2 as pointing away from Q2 in such that E2 is smaller than E1. But now, in order to draw E3, what we need to do, excuse me, I forgot an arrow, is to see that the x will be negative, so it will point away. Then the y will be positive, so it will point up. And it will point, the way that the electric field will point will be based upon this segment that connects the observed location with the source location 3. And the electric field will be like this. And now let us go to part B. So for part B, we have to draw the net electric field. So now these two will sum up, and the resultant would be this one at first. But you have to still sum it up with this other electric field. So you will use the parallelogram rule like this and draw the diagonal, and this will be the net resultant electric field, which we can easily label it as E net. But now, what if in the system of charged particles we decide to put an electron? Where would you put it such that the net electric field would turn out to be 0? Well, we'll figure it out through linear superposition. So, we know that these electric fields, they must sum up to be 0. So now we have to determine that this is the relationship from the fourth electric field from the electron based upon these other electric fields, and then we develop it all out to get this result here, this step, and then we can approximate it towards this step as well, and in this way you will determine the magnitude of R. And this can be easily taken as R hat, because within the formula you notice that the only value that is a vector is R hat, and so this is the only vector, and so we're going to apply R hat, and therefore we know that this is the value for R, and we know that R is the difference between the observed location and the source location, and in order to find, and since we know R and we know the observed location, in order to find source we just have to solve for it and determine this value with D, which is our final value, to where we could locate an electron within the space, which would be here, which perfectly contrasts with the net electric field which we drew before, which points towards here from point B. This is my exam wrapper for Physics 2. Thank you for watching.